So we are going to solve this Leetcode 2685, count the number of complete connected components today. So here basically given an undirected graph with n vertices numbered 0 to n minus 1, and we are given a edges array where edges is basically a edge between any two components, any two nodes of the graph, and we need to return the complete connected component. So basically what is a connected component first is a basically there we can go from that node to, and there is a path between any two nodes in that sort of component. So basically if I have a look at 0 1 2, I can from 0 I can go to all the nodes in this component 1 and 2. It's not for a connected component, it's not necessary that there will be direct edge. So basically if this edge 0 2 is not there, then still it will be a connected component. So 0 1 2 will still be a connected component, but we need to find the complete connected components. That means that there is a edge between every pair of vertices. So if I, let's say, have 5 nodes in my let's say this was also connected here, and so that what that means is I need a edge between, so 0 should be connected to 1 2 3 and 4. Similarly 1 should be connected to 0 2, then 3, and then 4. Similarly, so all my nodes should be connected. So if I take a particular node, let's say x, then this x should be connected to all the other nodes that are there in my connected component. So we need to find the total number of connected. So basically this will be one connected component, then this will be another one. So we need to, in our problem is asked that we need to find the total number of complete connected components. Okay, so if we do some sort of some math, then what we will so what we will find is let me draw. So this is 1, then 2, and then 3. So if I have a look at the number of edges that are there and my number of nodes which are there, so I have 3 nodes here, and the edges if I see are 1 2 and 3. Let's say now I take an example of 4 nodes. So I have 1 2 3 and 4, and now I need this one connected as well. So now my 1 is connected to all 3 nodes, 2 is connected to all 3, so all of them are connected. So this is a complete connected component. Now if I look at the number of edges and number of nodes, I have 4 nodes and number of edges are 1 4 5 6 edges. So if I have a sort of find a correlation between the number of edges and number of nodes, I can see, so I have n nodes and each node is connected to all the other nodes. So basically that means each node have n minus 1 edges, but we have duplicate edges here, so we are calculating this edge twice, any edge twice. So 1 is connected to 2 and 2 is also connected to it, so we can do. So basically this is the total number of edges we want with n nodes if we want our component, basically connected component, to be a complete connected component. So basically we can just check for this condition, and okay, so now I can sort of have a, let's say we can do it with a simple DFS traversal wherein, so this is my basically a visited array, and initially all the nodes are not visited. I start with 1, I mark it as visited, so basically I am visiting 1. now when I go, basically when I am visiting my DFS node, I can sort of keep a count of my number of edges that are in this current component and the number of edges that are in this current component. So basically I come at 1, so I will do node plus plus, meaning I have a one node, and for the edges I can do is edges will be equal to the number of neighbors this node has. So basically neighbors of, right? And now I go to, so now I visit each and every neighbor. I go to 2, 2 is not visited, I mark it as visited. I increment my number of nodes and I increment the number of edges it has. So again I increment it. So we will basically be calculating each edge twice. So basically I calculated this one for 1, now I'm recalculating it, basically putting it in my here again. So basically I will keep that in mind, and when our DFS returns, then we can basically, based on this condition, so we can calculate if we can, basically this current component is a complete connected component. Okay, let's try to basically code it. So first I will need to create this adjacency list. My adjacency list, I can have a map of integer, or rather than this, I can, what I can have it, because I know I have 0 to n minus 1 nodes. So what I will do is I will say it will be an array of lists, wherein I will say this is my graph and I will say this is my array list of size, and so basically this is my graph. Now for every node, basically this represents every node in my graph. I will say graph of I is will be new. So I will just initialize each node. Now I will go through my edges array, and I will say, so basically there will be an A edge from A to B. So I will, here I have two variables in A comma B, and my A will be just, this is just a cleaner way of writing things. I would have directly put the values in the my graph, basically my adjacency list, but this it won't basically be little bit of a less confusing. So for node A, so basically for node A I am adding this edge to node B, and similarly there will be, since this is an undirected graph, so this will be like this. So now I have my graph. Now what I will do is I will create my set. So basically this is for visited, and what I will do is I will start from the first node and I will check if this node is not visited. Basically this will say if visited will be true, so this is not, will say not visited. What I will do is I will calculate, I will call my DFS for this node with this graph and visited array, and I need to pass some other values. So basically what I will pass is I will pass this count or size So in Java we can't pass by reference, but we basically need to have these two values of the so the thing that I mentioned here. So I will pass to my DFS function this n variable and e variable. So basically this will return me the number of nodes in my current component, number of edges. This is a simpler way of writing things. So I will pass my counter here, and so after it returns my zero value, so basically this will be nodes, and node 1, this will be edges times 2. Remember, we included every edge twice, right? We were watching it twice. That's what. And what will be my condition for the connected component? So this is my connected component. So I will say, let's say this is e dash, which is actually like 2 times e, right? So basically we have calculated these 2 times. I will take care of it here only. So I will check if so my number of nodes times a minus 1. So basically if I have these many nodes, let's say I have a nodes, then the number of edges I need in my connected component is this by 2, and in the number of edges here are b divided by 2. So basically calculate it twice, so I can remove this 2 from this, and I can do answer plus. I can initialize my answer to be 0 here, right? And in the end I can just do return answer. Now I need this private, this function dfs, wherein so basically I'm going with I. Let me put the values. I have my, this is my graph, and but then I'm passing visited, this is visited, and I'm passing count, so this is count. So first of all, what if visited contains I? So basically I have already visited it, I will just return. Otherwise what I will do is I will increment my number of nodes, and I will say count of 1 plus equals to, so what this will be, it will be graph of I dot size, right? Basically this will be my number of neighbors for that particular node, and now what I will do is I will say this is my neighbor, so these are my neighbors for ith node. I will check if this is not visited, or mm, we also need to mark it here as visited dot add I. Right now I have marked my visited, I have incremented my number of nodes, I have incremented edges. Now I am going through each and every one of my neighbor. If my neighbor is not visited, then I am calling the DFS for that neighbor. And in the end I will return. So this should work. Let's see. Why is it giving wrong? There was a small issue. We need to basically, so what we did here is, before every iteration we need to initialize those values rather than keeping them same. That way we will have duplicates. Just submit it. Okay,